8. Roman concrete in maritime defense. A wall is brave on land. At sea, it needs chemistry. Roman engineers learned to pour stone that didn't just survive waves, it made waves do the work. Ports, moles, and breakwaters rose where storms had the last word, and centuries later, those shapes are still there, laughing quietly at salt. Here's the move that shouldn't exist that early. You take burnt limestone and volcanic ash from very specific places, the kind that slept near Naples. You mix it with seawater, then pack it into wooden forms sunk like coffins just below the surface. Wooden caissons hold the shape, rubble fills the belly, and the cement paste snakes through voids. The ocean isn't the enemy, it's the catalyst. Why does it lock so hard? Pozzolanic ash. The Romans didn't say pozzolanic reaction, but they knew that ash from Campi Flegrae and Vesuvius behaved like sorcery. When lime meets water and that ash, it doesn't just set, it keeps reacting, weaving crystals through the mix. In the sea, chlorides and magnesium don't just attack, they get folded into new minerals. Cores pulled from ancient harbor works show aluminous tobermarite and philipsite, rare needles and frameworks growing inside the concrete like a mineral forest. That's not a surface trick, it's a living cure. Action on the pier looks like this. Crews assemble timber boxes on barges, tow them out on slack tide, sink them with stone, and start feeding the mix. Divers, yes, divers guide rubble into voids and tamp with poles. Lime and ash slurry flows, kisses seawater, and begins to set even as waves slap the forms. The forms don't have to be forever, they're scaffolds. Once the mass grabs, carpenters strip and move them down the line. The mole grows like a reef humans decided should exist. Engineering is everywhere you look. Lime has to be fresh. Ash has to be the right stuff, ground fine, not contaminated with beach sand that dilutes the reaction. Ratios aren't numbers on paper, they're textures under a mason's trowel. Too lean and the mix starves, too fat and it cracks. Aggregate matters. Tufa blocks, broken pottery, quarry scraps, graded so voids interlock. The whole thing works because somebody taught crews to read mud. We have receipts with teeth. Core samples from places like Portus, Cosa, and Caesarea Maritima show the mineral phases that only form in long, wet cures. Microscopy reveals crystals binding at the interface of ash and lime, especially where seawater seeped. Mechanical tests on those cores after nearly 2 millennia show strengths that embarrass some modern mixes, not because the Romans had super cement, but because their recipe married the environment instead of fighting it. Logistics decides whether a recipe changes a map. You need ash shipped in tonnage, lime kilns that keep up, barges, carpenters who trust wet wood, and divers who don't panic. The empire made it possible. Quarries stamped blocks with legion marks. Kiln sites dotted coasts. Roads delivered barrels to harbors. Harbors birthed fleets. Fleets fed roads. The loop closed. A general could plan a campaign around a port that didn't exist last year. The impact is simple and huge. Secure harbors mean you can stage grain, repair hulls, and launch on your own clock. Breakwaters tame swells so cargo doesn't drown at the dock. Fortifications on those moles project force ballista stands, watchtowers signal fires. A coastline stops being edge and becomes infrastructure. When storms hit, the mole takes it, fractures a little, then heals from the inside as mineral growth continues along microcracks. That self-strengthening is the part that feels like cheating. There's a catch: source dependency. Not all ash is equal. The best pozzolana came from very few pits. Move away from that supply and the recipe drifts. Substitutions get made: river sands, different ashes, and performance slides. Later builders still made Roman concrete, but without the magic ash, the long-term mineral party never started. That's how you lose a technology in slow motion. The form stays, the function fades. From walls that learn to love seawater, we're heading to warheads that learn to love air. Projectiles got smarter by design, and even the fins tell a story. 9 Hellenistic siege bolts with bronze fletching. Get close to a Hellenistic bolt and it tells on itself. The head is iron, mean, and tapered. The shaft is wood, straight and hard-grained, but the tail, it gleams. Bronze veins fixed where feathers should be, not decoration, direction. Someone decided spin and stability were worth metal. Accuracy teaches cruelty. Once you can pick a face, you stop aiming at crowds. Stakes are simple. Stability over range means you can aim at armor instead of air. Siege engines, gastrophetes, ballistae throw fast, but turbulence punishes sloppy tails. Feathers warp with rain, tear under acceleration, and twist when launch shock hits. Bronze doesn't care. Cast veins hold angle, mass, and shape under stress. That turns a big, ugly dart into something that flies like it believes in itself. Action starts at the mold. Foundry workers pour bronze into 2 or 4 vein patterns with precise thickness. Too thick and you drag, too thin and you sing and flutter. The veins either sleeve onto a tenon at the rear of the shaft or rivet through a metal ferrule locked with peened pins. Mass distribution shifts back just enough to tame pitch. Some veins tilt a few degrees, giving a slow, steady spin without rifling, enough to average out tiny asymmetries in head and shaft. We've got receipts in dirt, not just drawings. Recovered bolts from Hellenistic and Roman layers show metal fletching, bronze or sometimes thin iron, and wear on vein edges from airflow, not museum fingers. Microscopy finds abrasion that matches repeated flight. Reconstruction tests with comparable weights and vane angles show tighter groups at range and less yaw on impact. The story that sounded like overkill becomes arithmetic. Same engine, better tail, more hits where you meant them. Engineering lives in tolerances. Casting repeatable vanes needs consistent alloy and molds that don't warp after 10 pours. Attachment methods decide whether vanes shear on launch. A sleeved ferrule spreads load, simple nails split wood. Crews sort bolts like bankers by weight by balance point because a magazine of identical isn't identical unless you make it so. On the line, gunners mark rails for a bolt length and vane diameter, tuning the channel so the vanes don't scrape and steal speed. What nobody knew the first time a bronze-fletched bolt punched a shield boss dead center was how it would change sighting. Predictable trajectories make sight marks meaningful. Scratch a notch on the tiller for 100 paces with north wind, and it works tomorrow too. Officers stop waving in the general direction of an enemy engineer and start telling a crew, take the man in the blue cloak. Control breeds cruelty and precision at the same time. Cost is the counter-argument. Bronze is copper plus tin, both strategic. Casting shop time isn't cheap. In long sieges, metal is coins you can't spend twice. That's why these bolts don't show up in heaps like peasant arrows. They're for priority targets, artillery, ladders, officers, or for opening minutes when you set the tone. Crews police the field after sorties, recovering metal tails by memory of where the shots fell. The ground becomes a ledger, bolt here, vane there, repair later. Maintenance is its own doctrine. Bent vanes don't get bent back forever. Work hardened bronze cracks. Crews carry stake blocks and little hammers to true edges, files to clean burrs that hum and steal speed. The enemy hears the hum too, by the way. A singing bolt tells a story about launch issues. Gunners listen, adjust wax on rails, oil sliders, and whisper apologies to a machine that wants clean flight. Impact is both literal and social. When a bolt with metal vanes lands where it's aimed twice in a row, defenders change posture. Heads go down, standard bearers kneel. Engineers work behind mantlets instead of on top of ladders. The psychological dividend shows up fast. If standing tall makes you a target, everybody learns to be small. Siege rhythms slow. The side with better tails steals hours from the calendar. Complications show up in weather. Rain turns wood shafts heavy, bronze shrugs, but water inside vane sleeves can freeze or swell fibers. Crews grease joins, wrap ferrules with gut, and bring bolts inside at night like they're animals that need warmth. In dust, sand chews trailing edges. 1,000 launches build a lip that disturbs wake. You file or you accept drift. No tool stays sharp on its own. By the end of a campaign, the lesson is boring and powerful. A vane you can trust makes every other part of the shot worth caring about. Wind calls, range counts, trigger breaks. Bronze fletching reads like decadence until you track casualties by hour. Then it reads like policy. From here, the story shifts from projectiles that fly true to machines and tricks that made battlefields think. Kinetics, traps, and automata. Up to now, we've watched levers and chemistry behave. Next, we watch energy get banked, released, and faked with intent. Kinetics, traps, and automata aren't just gadgets, they're arguments with gravity and attention. When to spring and choose when to let it go. Stretch a rope and hide it where a horse wants to step. Build a device that moves at the right moment and everyone in earshot decides the world has a mind. The aim isn't damage, it's doubt. Make men second-guess their own feet. Frame it like this: energy capture, mechanical logic, and deception. A battlefield is a tangle of human decisions. These tools bend those decisions before steel ever touches skin. A repeating crossbow that prizes volume over precision teaches militias to hold ground they shouldn't. Caltrops and Tanglefoot fields make cavalry commanders second-guess an open meadow. A war elephant, dressed and drummed, becomes a wall that hears. A carved head that roars on cue or a drum that beats itself isn't killing anyone, but it's killing nerve. We'll keep our rule tight. Text sources crossed with machines we can build today without cheating. Manuals that show hoppers and levers, battlefield layers with tetrahedral spikes, training gear for animals that carried towers on their backs. Where myth barges in, we file it under interesting if constrained and park it by the math. The stakes are morale and momentum. Machines that act like mines don't need to be perfect. They need to be consistent enough that men build habits around them. Traps that think ropes, stakes, pits placed with a mapmaker's patience. By minutes that archers turn into fear. If that sounds cold, that's war through a carpenter's eyes. Everything is about to tilt forward when a hopper-fed bow starts clacking in the dark. Then a meadow bites back. Then sound itself becomes a hammer. And somewhere in the back, a gear train is quietly counting to an answer. 10 repeating crossbows of East Asia, Chu-ko-nu. The sound comes first, clack, hiss, thud, not one bowstring, dozens in rhythm like a loom weaving through the dark. On the wall, farmers in quilted coats cycle a lever over and over, eyes fixed on a lane below. They aren't marksmen, they don't need to be. The Chu-ko-nu turns fear into work. Stakes are blunt and brutal, volume over precision. A standard bow puts one arrow where a trained hand tells it. A repeating crossbow empties a hopper into a human-sized rectangle at 30 paces and calls it a night. Against skirmishers probing a gate, raiders under moonlight, or a breach packed with men who think they're fast, sustained fire denies space. You don't have to pick a man, you paint an area and make it poison to stand there. Action lives in a simple machine that hides good ideas. A wooden stock carries a short, low draw-weight bow lashed to the front. Above the track sits a box magazine, a hopper filled with short bolts. The top cover guides them, gravity does the rest. A single lever hinged near the rear does double duty. Push forward to draw the string with a slider, pull back to release and chamber the next bolt. It's a human-powered cam without the fancy metal. One motion, one shot, repeat until the box is empty or your shoulder begs. Surviving specimens Ming era and earlier show the trick. A sliding bolt carrier linked to the lever by a simple tongue-end slot, a sear that isn't a tiny catch so much as a step on the track, and a magazine throat cut to drop a bolt exactly when the string reaches home. Manuals diagram it like a kitchen tool. Crew drills read the same. Lead with the left foot, keep the lever in the groove, watch your fingers. Rate of fire DMOS in modern reconstructions hit 10 to 12 bolts in 15 seconds without breaking a sweat, and that's with caution for cameras. In a real panic, faster happens. Engineering is humility. Draw weight stays low, often under 100 pounds, because the lever trades stroke length for speed and because the frame is wood. The bolts are light, sometimes with small iron heads, sometimes with simple sharpened tips. Effective range is close, 30 to 50 paces where a man can see eyes. Ergonomics matter, a butt that fits a shoulder, a lever you can run for minutes, not seconds, and a magazine you can refill by feel. Standardization matters too. Bolts cut to one length, heads seated to a line, hoppers sized to a handful count so resupply doesn't stall. Tactics wrap around limitations. On open field, militia with Chu-ko-nu stand behind stakes or pavises, forcing enemies into lanes where dense fire matters. On walls, they work in banks, one line fires while the next refills hoppers and the third rests. At night, when precision archery sleeps, the repeater stays awake. Harassment fire isn't about kills, it's about keeping ladders off stone and sappers from thinking straight. Poison-tipped bolts appear in enough sources to take seriously. Light heads dipped in aconite or other nasty brews. A scratch becomes a countdown. Impact shows up in behavior. Raiders test a gate with a rush, hear the clack and slow without a trumpet. Commanders who rely on shock learn to dislike alleys. Cavalry dismounts in places where they'd prefer to ride. For cities with outstanding professional archers, the Chu-ko-nu is a labor multiplier. You train farmers to level a lever and keep cadence, not to read wind or draw to the ear. It democratizes denial. The soundtrack of safety is mechanical. Once enemies hear it, they start planning around your noise. Complications are honest. Range and penetration are limited. Against lamellar or thick leather, bolts bruise and stick rather than punch through. Crews compensate by aiming low ankles, thighs, faces behind shields, or by flooding a point until it turns. In rain, wood swells and magazines drag, strips of oiled silk and waxed lids help, but you feel the grit. In cold, hands stiffen, crews rotate more often. Springs not here, the bow is simple, strings fray. Spare bow arms hang on pegs. You swap the whole limb when something cracks. Maintenance is continuous. Wax the track, oil the lever pivots with tallow, keep the magazine throat smooth so a warped bolt doesn't jam the whole rhythm. Ammunition discipline is doctrine, bolts sorted by straightness and weight, misfits thrown to the pile for hand bows where a gifted archer can compensate. The Chu-ko-nu demands average parts to stay average in the best way. Fear isn't theatrical here, it's arithmetic. When men learn that stepping into a cone near that corner means being tapped 5 times in as many seconds, they stop stepping. That shapes nights which shape weeks. A repeater on a dark parapet doesn't look like progress the way a shiny blade does. But listen to the clack long enough and you hear a city teaching itself how to hold. Punic War Caltrops and Tanglefoot fields. Meadows lie, they look soft and open, a promise to cavalry that speed will solve everything. Then a horse screams, a line buckles, and the ground reveals its teeth. The simplest weapons in the Punic world didn't fly or burn, they waited. Stakes are ugly and efficient. If you can maim a horse, you don't need to kill a rider. If you can make a cohort slow down, you don't need to be stronger, you need to be ready. Caltrops and Tanglefoot fields turn momentum into a liability. They don't win the battle alone, they make sure the other side stops long enough for your missiles to do the talking. Momentum's a feeling, kill that and you kill courage with it. Action looks like carpentry with malice. Caltrops are tetrahedral, 4 points, always one up. Iron or bronze, sometimes even hardened wood with metal tips, forged by the sack in shapes a blacksmith can make while half asleep. You scatter them where hoofbeats will concentrate, gaps in hedges, the mouth of a defile, the tempting dip just before a gate. Under brush, under chaff, under a dusting of loose earth. A horse puts weight on one, the point punches frog and tendon, and the rider's world flips before he understands why. Tanglefoot is the bigger cousin, ropes, vines, and stakes set to ankle height, sometimes at 2 heights for horse and man, stretched across lanes you'd swear were clean. Punic crews drive low stakes at staggered intervals, lash them with cord dipped in tar to resist rot, and then dress the ground to erase the geometry. Add concealed pits, A shallow trench with brush and dirt over wicker or sharpened palisade roots facing backward so anyone who stumbles forward meets barbs. It isn't elaborate. It's patient. Receipts live in dirt and lines. Archaeological layers from battlefields around Iberia and North Africa cough up caltrops like teeth, spikes with hammered sockets or integral points bent by impact. Classical descriptions talk about tribuli and crow's feet cast in handfuls, flung from cloaks as skirmishers retreat. The geometry stays consistent because the physics demands it. 4 points make 1 point always greet the sky. Roman manuals later pick up the trick and institutionalize it, which tells you how it felt to meet it. Engineering is placement density and memory. Too sparse and cavalry dances through, too dense and your own men bleed. Crews pace strides, count heartbeats between stakes and map their trap in whispers. Officers carry stick charts, sketched grids of safe lanes, so when the moment comes to chase, they don't donate ankles to their own invention. Signals mark paths, a tuft of grass tied oddly, a stone turned on its face, a strip of dyed cloth only your side knows to look for. Impact arrives in seconds. A charge meets an unseen edge, horses bunch, riders flail, and the formation that wins by being one animal becomes 800 animals trying not to fall. Javelins find backs, slings crack at faces. Arrows that would have been outpaced by speed now bite into hesitation. The meadow becomes a machine for breaking courage, and the machine hums as long as men fear what they can't see. Complications are fair. Rain loosens stakes, turns pits into tells. Dust storms expose metal glints. Enemies learn to send light infantry ahead with wicker screens to sweep lanes, or cattle to trigger traps first, cruel math with hooves. You answer by mixing patterns, caltrops clustered where they expect ropes, ropes where they expect pits. You plant a few obvious spikes to make them careful, then hide the real teeth a step to the left. Friendly risk never leaves. Maps get lost. Units rotate. In the dark, your own runner forgets the third tuft means turn. So you build rituals. Every dawn, officers walk the edges, renew markers, pull any exposed points, and brief the fresh cohorts. A trap that forgets its maker is just hunger. By the time a Carthaginian commander waves his hand and a cavalry wing hesitates to obey, the trap has already done its job. It didn't need to bleed much. It needed to teach the field to argue back. And once a meadow learns to bite, even heroes look down. 4 Greek fires, the water-burning inferno. They called it sea fire, Roman fire, the gift that made the Bosporus a wall. On the deck, it felt like betrayal. Water stopped being safety. A bronze nozzle swung like a serpent's head, a bellows team heaved, and a stream of burning glue stitched itself across planks and men. Buckets did nothing. Oars dropped. The ship tried to reverse, but the fire followed the wake. Start with the stakes. Constantinople didn't have the luxury of losing. Every few generations, a navy parked outside those walls and waited for history to blink. Greek fire turned those sieges into funerals for fleets. Control the straits and you control the grain, the tribute, the message that the empire still had teeth. Entire campaigns hinged on whether a siphon would cough when the moment came. Action looked simple because the crew made it simple. A furnace below kept a thick incendiary near the edge of boil, resinous, oily, eager. A pressurized tank sat forward, braced into the hull. A hand pump or tread-driven bellows built head, and a crewman, usually the one who didn't flinch, manned the bronze tube, close range only. You lined up bow to bow, waited for the roll to meet you, then stitched flame along their deck seams. The stream hit, spread, and clung, finding rope, tar, and skin. Even spray from the collision didn't cut it. The mix took water as a dare. What was in the blend? The exact recipe vanished on purpose. Byzantine sources treat it like a state religion, guild knowledge, inherited, compartmentalized. But the bones are plausible, a petroleum-based naphtha or heavy distillates, enriched with pine resin for stick, sulfur for bite, maybe pitch for body, and quicklime for the party trick. Quicklime reacts exothermically with water, so dousing feeds heat instead of starving it. Add a thickener like rosin or wax, and you get that tar-like persistence witnesses talk about. Men scraping flames with knives because their hands no longer feel like hands. We have receipts that aren't just stories. Ceramic siphon nozzles show heat bloom patterns and soot that speaks of repeated use. Written accounts describe pressurized deployment, throwers, and squeezers, not just pots lobbed by hand. There are depictions of shipboard tanks and forward mounts. They're stylized, sure, but they agree on the basic idea, a controlled jet, not a toss jar. Chemical plausibility tests using petroleum, resin, and lime show that the right ratios make flames that grab wet surfaces and refuse to slide off. It isn't magic, it's chemistry with malice. Engineering is where it stops feeling like myth. A pressurized tank has to be more than a pot. Riveted bronze or copper seems caulked with hammered metal and resin, pressure tested before sailing. Bellows need non-return valves, leathers that survive heat, and a rhythm the crew can keep while the deck tilts. The nozzle is not a tube by accident. Constriction shapes the jet, a flare reduces backflash, and an optional igniter, maybe a toe of burning hemp at the tip, turns the first droplet into a fuse for the stream behind it. Then there's shipboard risk management, the part nobody sings about. You're running a furnace on a wooden platform surrounded by rope, pitch, and people. That means fire breaks, wet hides hung around the siphon station, sand bins, a second team with soaked felts ready to smother any backfire. The tank and lines sit behind a shield to block stray arrows. The crew drills for misfeeds. If the jet sputters, you don't peer down the nozzle, you cut pressure and pull the igniter away. If flame crawls back, you flood the line or jettison the head. The man on the valve is the calmest in the Empire. On the water, the impact was arithmetic. An enemy commander planning to crowd your hull with boarding hooks has to plan for a fire lane instead. Grappling ships become liabilities, close formations turn into kindling. The psychological effect is worse. Fire that doesn't respect water breaks instincts at the root. Crews jump early. Captains refuse to press the angle that wins them the ram because they don't want to enter siphon range. With enough fear, you don't have to hit many to move many. Anxiety extends your range farther than pressure ever could. Greek fire saved Constantinople more than once. During the Arab sieges in the 7th and 8th centuries, night attacks lit water like a festival of terror. Accounts talk about ships burning from bow to stern, about waves carrying fire. That last bit gets embellished, but the image lands. If a stream lights floating oil slicks and resin flecks, you get the illusion that the sea itself turned. Illusion is enough. Crews fight the picture in their heads, not the chemistry in your tank. There's a reason the formula didn't travel well. This was a supply chain, not a trick. You needed access to petroleum, tree resins, lime kilns, metalworking capable of pressure vessels, and crews trained to handle all of it without setting themselves on fire. Even when enemies captured siphons, they couldn't make the brew behave. Substitution failures show up later. People try pine tar without the petroleum fraction or oil without the lime, and end up with smoky bonfires that wash off with a bucket and a prayer. Mystery wasn't branding, it was deliberate psychological warfare. Make the enemy doubt their copy before they light it. Mystery isn't a flourish here, it's policy. The Byzantines compartmentalized production so no single defector could hand over the crown. Workshops handled components, ingredients arrived sealed, and the last mixing step happened near the docks. Chroniclers hedge their words, and the silence around specifics is its own evidence. If this was a casual recipe, you'd see it everywhere by the 10th century. You don't. Was it perfect? No, range was short. Wind was a bully. A badly timed roll turned a steady jet into a spray that kissed your own prow. Crews countered by choosing their moments, lee of a wall, calm in a current, ambush angles in cramped waters. They built specialized fire ships with reinforced fronts and cut-down rigging to reduce catch points. They didn't trust luck, they rehearsed it. Here's the line that matters. Greek fire didn't break physics, it exploited the ones we hate. Adhesion, exothermic reaction, pressure flow. It made the sea a partner, not a refuge. Once you grasp that, the rest of the century looks different. Because if fire could hunt in water, then air could hunt in earth. From decks to dirt, breath itself was about to be a blade. Fear is the medium, these recipes just taught it how to travel.